Hi everybody, welcome back. Okay, so this time we're going to be going over simple numerical methods. Now, if we go back to what we've been learning so far, we have an equation that looks like the following. It's our continuity equation. It simply says the divergence of our velocity should be equal to 0. Now, why is that? Well, because we have incompressible flow, and if we have divergence, that means that the particles are getting further apart. If they get further apart, the density is going down. If they get closer together, density is increasing. They're not allowed to do that, at least in our particular cases. So that means our divergence is equal to 0. Now, various ways we can write this. The way I'm going to write it is this right here. So it simply says that our partial derivative with respect to x for our velocity in the u direction, plus our partial derivative with respect to y for velocity in the y direction, is going to be equal to 0. I know I said u direction, but you get what I mean. The x component and the y component of velocity. This should be equal to 0. And that equation is very fine and doesn't seem all that important for you. However, you've taken calculus and you know the derivatives are simply slopes. If I want to, I can rewrite this as a slope. So like, for example, delta y over delta x is simply y2 minus y1 for x2 minus x1, or y final, y initial over x final minus x initial. So if I want to, I can rewrite that as follows. u2 minus u1, x2 minus x1, v2 minus v1, y2 minus y1. And if I do that, I have a way of actually solving for my continuity equation, which will work out pretty nice. Okay, so let's go down here a little bit and see if we can figure some things out. As a note, for this to equal 0, it doesn't mean that these two perfectly work out. If I drop my particle somewhere in the flow, I actually have to figure out what angle it needs to go using the gradients, or using the derivatives. And I can figure out which direction I need to go to keep it equal to 0 to follow that path properly. So we already have a U matrix opened up for us. Looks like this. It's 12 by 12. We have a V matrix. We have an X matrix, which I'll see if I can find real quick. I'm in the way, so I'm going to move myself out. And you see that it only changes in the X direction. And we have a Y matrix, which only changes in the Y direction, which is just going down the rows. Okay, so we have all of those things. Let's get back to our live editor. And so what we're going to do is we are going to slice our matrices such that we have a U left and a U right, a V top and a V bottom. As a note, top is actually going down in this case. And from that, I'm going to get a du and dv. I'll do the same thing with dx and dy, which I want you to have to do, and we'll have our answer. So let's try this out. Shouldn't be too hard. Okay, so if I remember correctly, let's see here. This is going to be u. I'm going to index it, so put a bracket there, parentheses there. There we go. And I need rows and columns, so I want all the rows, and I don't want that first column. So I'm going to want all the rest of the columns. I need to start at 2. I go to the end. So I want all the rows, so I put a colon. I want to skip 1, just like I say to do up here. I got that. Let's see, did I do that right? Oh, I didn't. That was the right side. 1 to end minus 1. There we go. I do want that first column. I just don't want the last column. And this one right here will be very similar. All the rows, I'm going to start in the second column and go to the end. As a note, end is a wonderful little variable. It simply says however many rows or columns there are, and I can then subtract or add it if I need to. And V top, I'm going to get everything, including the first column, but not the last, right? The first row, but not the last row. So this time I got to be careful because I only want rows. Okay, so I want to start at the very first row, which is 1. I want to go to the end minus 1, and I want all the columns. Okay, very similar to the last one. I'm just moving around a little bit. And then I want to start at the second row and go to the end, and I want all the columns. Okay. So I have my U left, I have my U right, I have my V top, I have my V bottom. I can go ahead and calculate du then. So that's going to simply be U right minus u left. Okay, I've got that. And dv will be v top minus v bottom. So I'll have a du and a dv. That takes care of the top part right here. Now I need a dx and a dy. Now the great thing is, if I go back to actually looking at my variables, I can see something really nice here. For one, I notice that it's every single column, at least for x, is the same value. So that means x2 minus x1, I actually did some math, I found that that was the same as x3 minus x2, which is the same as x4 minus x3. So dx is actually just one value. I don't have to do any crazy math here. So I'm going to go ahead and plug it in down here and just help myself out. And let's see, 102.2439, I'm picking one at random here, minus 100.6411. That's 1.6028. So dx is equal to 1.6028. Okay, that's good to know. I'm going to go ahead and write that down for myself. 1.6028. Okay, let's do the same thing for y now. As a note, I can also do this in other ways. Like, for example, I could just do this. dy is equal to y, I pick a row, which I'll just make 2. Pick a column, 1. Doesn't matter what I do. Minus y, 1, 1. So second row, first column, minus first row, first column. That should give me dy. And then finally, I can get du dx. Du divided by dx. Okay, so du divided by dx. And I can get dv dy. If I wanted to, I could then use this information. That's a db. That's a dv. There we go. To solve my continuity equation. Yay, we did it. It's so perfect. However, I have this section right here called Not So Simple Numerical Methods because it's not actually that simple. Now, why is it not that simple? Well, the biggest thing is if we actually looked at where our data was, u, v, x, and y were all perfectly overlapped. The u and the v data were taken exactly where the x and the y data were taken. That was great. When we started calculating du dx or dv dy, we actually moved it off because this is more or less an average. I am halfway in between one y value and another y value, or one v value and another v value. And my du dx data is halfway between one u value and a second u value. And they're not overlapping. Du dx and dv dy are not overlapping anymore. So we're going to have to figure out how to fix this. And I'll do that with you next time. So thank you for listening. I hope this helps you. And I'll see y'all later. Bye-bye.